Hi folks, we had a really good time at Autodesk University 2019 this year, and I learned a ton. So if you use Fusion in any way to machine or manufacture, this is a recap of all of the awesome little tips, tricks, and nuggets and classes that we went through in Las Vegas. Enjoy. First new feature at the bottom of your screen in the manufacture workspace is a new icon, Synchronize Active Setup. I've got both of these options checked. Sync View with Active Setup and Sync Visibility with Active Setup. What that does is when I switch my main setup to this alternate setup where I'm obtuing the part, and oftentimes you're inverting your Z-axis because you're holding it from the exact opposite direction. Watch what happens. Hit Activate. It flips the part around so it's oriented now with my Z up in that ISO view, and it has toggled the visibility to show my Op2 work holding. If I toggle back to the main setup, it goes back to there. Absolutely awesome. This is a nice quality of life improvement when it comes to either switching between Op1 and Op2 type setups, or if you've got a part that you're moving through, say turning, then over to milling or machining. That was a tip that Rob Lockwood covered in his class, and I would really encourage folks to watch the recorded view of all these classes. Card here to the NYC CNC page where we have a copy of the presentation and class that we did on 5-axis machining, and we've got direct links to the various classes at AU that we took and are referring to in this video. Rob's class also covered a really innovative way of handling your Fusion 360 templates, but not the templates you're thinking of in overall setups. Let's first walk through how we've handled our 5-axis setups, then I'm going to show you Rob's, and we're going to kind of compare and contrast them. So let's say I want to machine this part. First thing I'm going to do is new component, stock, R for rectangle. We'll sketch a rectangle on this face, and I would probably take more time to dimension it such that it matches stock that we have on hand. I'll extrude it up, and then I'll switch the direction to two sides. I'll extrude it down. I click OK, and what I can now do is change the opacity to 30%. This lets me see how the part is sitting inside the stock. And on most 5-axis workflows, especially for one-off parts, you'll benefit from having an additional amount of stock below the part so that you can tab it off and have an ample clearance below your vise. So let's say drag this down a little bit more, and we really don't need very much material up there. So you can see I'm only able to drag it in 0.1 inch increments. So by dragging it, I can see which dimension it is, and I can either type in the dimension, or if you zoom in Fusion, it actually is zoom aware. So as you zoom in, it gives you finer adjustment ranges. So 0.55 is perfect for there. Click OK. We have our part, we have our stock. I want to lock them together. Assemble rigid group. I'll pick the component and the stock, click OK. So those now move together. I then go into our work holding folder. Make sure I'm active on my top component. I'll pick whichever setup that we have. This will be our standard smaller self-centering vise. Insert into design. We've got these files available over on the NYC website. Just click OK. Assemble as-built joint. I want to join the bottom of my 5th-axis base to the origin of my Fusion model. Click OK. Think of that like a ground. I'm locking this base at the center of my global coordinate system, and having it grounded lets us move the jaws in and out. If I hadn't grounded it, when I try to move the jaws, I'm just going to drag the whole part around. J for joint, and I'm going to then select the origin coin at the bottom of my stock and that joint origin that we have at the center of our self-centering vise. Click OK. Drag my jaws in. I just do this part by eyeball. And for the first time in the history of using Fusion 360, I actually care about capturing the position. And I now have my part held exactly where I want it at a known location. I could take advantage of the fact that this is a 0-point system, so I wouldn't even have to probe if I didn't want to. And I've got everything ready to go, and I can even use this to check my holder collisions with my part. Rob's method is totally different than that, and I actually really like it. His demonstration was on a 5-axis part. I'm actually integrating it already with our lathe workflows for our new ST20Y. So we have a lathe master template. And if I open up that template, it has our royal chuck, It has a piece of stock and it has a part placeholder component. This is key. I'll explain in a second. Under modify, change parameters. See how that's the FX? I chose to pin that to the toolbar so that it stays up here because I use it a lot now. We've got the two variables I care about. In this case, the stock diameter, so let's adjust that to say 1.5, and the stock length, that's how far it's sticking outside of the collet. So 3.5 I think worked for this example. We also have, under manufacturer space, pre-programmed cam. And this is the key to this workflow. And I give Rob a lot of credit for coming up to this. Card here to his YouTube channel where you can see the videos that he has put out, which are excellent. This part placeholder lets you insert a component underneath that. And by having this placeholder or container component, you'll notice under the manufacturing workspace, I edit the setup, the model is already chosen as the part placement container. So anything I insert as a subcomponent within that automatically becomes part of my Fusion setup. So this massively reduces the amount of work I have to do to get from a solid model to actual G-code ready to run at the machine. I'm going to reiterate that point to make sure it sinks in. We create a component called part placeholder. We then choose that part placeholder component in our cam setup as the model. What that means is that anything that we put inside of that component or as a subcomponent automatically becomes part of the cam setup model. If we didn't do this, we'd have to be constantly deleting and adding new top level components, and we'd thus have to go into our cam setup and be re-picking the model component each time. I'll give you an example. Let's say we want to machine this chest pawn. Under design, I'm going to activate my part placeholder component, right click, insert, hit J for joint. Normally I'd like to grab the tip of the part. I don't have a good joint origin. That's okay, I'll use the rear end of it. Because now I can just drag it back to show it there. I set my stock opacity to 30 so I can see it. I can go back and edit that joint, move it forward just so we have enough to skim off the top. Click OK. If we needed to change our stock size or stick out here, we could. Go into manufacture, right click, generate toolpath. Turning is actually a great example for this workflow because most of the turning cam in Fusion 360 is model aware. I've already got my facing operation. I've got my roughing. I've got my roughing with a V insert. I've got my finishing. Grooving, I probably won't need. I don't have that selected as rest machining right now. We're still working on our master cam template, but I won't need grooving here, so I can just delete it. Parting is good to go. I'm not using a drill and I'm not threading on this part. I am potentially done. And again, once we nail down our tooling and our feeds and speeds for our lathe, we can have this master template that works great, especially on these simple 2-axis lathe parts. Speaking of 5-axis workflows, Phil Buttersworth did an amazing class on showing how to program 5-axis parts very quickly. Like, part shows up and within 2 to 3 hours, you're holding the finished machine part in your hand. So he asked for a sample part off of the Johnny 5, and I thought, you know what? I'd love to see how Phil would tackle this part right here. It's a fairly complicated part that will definitely benefit from a 5-axis workflow. Here's what blew me away was when I was thinking about machining this part, I was thinking about the traditional setups. The stock that we're starting with is almost certainly going to be 4-sided. So I'm sitting here thinking, do I hold it like this? Or should I rotate it up and hold it like this? When I hold it like that, I may not be able to have great access to get to some of these features down here on the floor, depending on where I'm trying to reach in. But if I had gone the other way, it's not ideal. And the light bulb moment in Phil's class was when I realized you don't have to hold it in a traditional 90-degree angle. What Phil recommended was rotating it up about 45 degrees, like you see here, which is going to give us the right mix to get access to all the features that we need to, including, critically, this bottom feature here with the curve, which is the most soft jaw friendly, because we still need an Op2. It's not very much work in Op2, but we want a good datum and a way to hold that. Holding it this way gives us the right access to the most features, and using some solid modeling lets us create a approximation of what we could do to window machine this. So we've done a Wednesday widget on this before, but basically you're buying an oversized piece of stock And everything you see here is monolithic. It's all out of one piece of material. These tapered cones and this bottom lip here serve as supports that you're machining as part of the part, including even having access holes so that you can drill or tap certain areas as needed to finish this off and get as much done as you possibly can in that first setup. I forgot to mention, let's say you're going to surface this outside edge. You don't want all these slots here. It's going to just wreak havoc on your toolpath. There's a couple different ways we could tackle this. We could copy and paste new, and we could go into this new component and we could start using direct modeling features to go through and individually delete each insert. Fusion Direct Modeling is actually really quite powerful, and this is a really good outcome, but it's a horrible way to get there because it's incredibly tedious. And it's the same shortcoming if you went into the surface environment and you did a create offset patch, you selected that face, and you did a zero distance offset. It's a really common workflow. Here we've created that skin or that patch that we can use, but I've still got to go through. I've got to go through and take the time to get rid of each one of these slots. The better way, create sketch on this face, P for project. Now I'm going to project those two edges. If I turn off my component visibility, you can see I've got those two purple edges, and then create extrude to object, extrude to that point right there, click OK. I've now created much simpler. We can then do create offset, and we can select these with zero distance offsets, click OK. And you can do additional trimming work as needed, but a much more enjoyable way to create a nice, clean surface to use for those 3-axis toolpaths. Laurens Weinschenk, who you may remember from a really awesome factory tour we did over in the Netherlands, did a class that kind of recapped all the new things that have come about in Fusion 360 since the last Autodesk University, or basically in 2019. NC Programs is a major one. If you've ever gone through a part and thought, well, setup A, I want to post on my SC20Y, but a different setup or even a different part, it defaults back to that same machine, and you're thinking, wait a minute here, no, I want that to be on a different style machine or use a different post processor. More so, there's other things that you'd like to include as defaults. NC Program does that. In this example, we can save the name, we can save where it's going to get saved to, and most importantly, we can choose our default post processor for this file. We can save all of our post processor settings. We can even set different NC programs to post different sections of the code. So you can have an NC program to run your fixturing. You could have an NC program just to run this certain Op1 setups or just the surfacing setups. You then post from this, and it saves you a lot of right clicks, double checking settings, having to make sure you've got the right post selected. Laurens made this gorgeous 5-axis trophy for the AU Go-Karting Challenge winner. Shout out to the New Zealand folks, Scott and Gavin in particular, who delivered some pretty impressive results. More to come on New Zealanders doing crazy things later in this video. Again, link in the video description to watch the recording of Laurens' class. It's worth seeing him go into detail about what the settings do between steep and between shallow, and what's really cool is Steep and Shallow offers a multi-axis mode that's going to allow this toolpath to work on 5-axis machines. It's the closest thing yet to a single toolpath that can cover a lot of different geometries and be that kind of holy grail for a lot of toolpaths, at least where a projected toolpath will still work, meaning from a certain view, you can see all the geometry you want to hit. The other thing that Laurens covered in his class that was really cool was he showed how we can use the new inspect function under the extensions. So after this part has been machined, he's bringing in his Renishaw probe, and he's picking 5 points. You just pick as many points as you want. He's probing those points. Then the machine can actually output a file. He can bring that back in. And in this case, the green points were in spec, the red were out. He intentionally did this by incorrectly orienting the part on his Op2 fixture in the machine to show what that can do for you. Once that happens, there's some pretty cool things you can do where you can tell Fusion to go ahead and update a tool wear offset to remachine it, or to use logic to say, well, if it's out of spec, run an additional separate toolpath. Two of my favorite things that I learned about in 2019 were, number one, under the simulation, switch your colorization to comparison and then set the tolerance at whatever tolerance you'd like. This gives you red, green, and blue output to show where you either have stock remaining, which is blue, or red, which would be gouge. If you do this, make sure you at some point toggle off your model visibility, because if you do have a gouge, it will be shown in red, but if you have your solid model still visible, there's a chance that solid model will cover up that red gouge. It's great for all cam, but it's really useful for things like 5-axis cam, where you've got a lot of different setups and orientations, and there's a chance after programming dozens of operations, you might have just missed something, or you've got an incorrect setting in your toolpath. We use this now on every single part we do. The other feature is under Inspect Section Analysis. It is awesome for giving you a much clearer view when you're trying to look at certain toolpaths. I'm going to pick this face here, and this doesn't change my file, it just changes my view. And for example, let's say I want to see, turn that back on, I want to see what's happening at the bottom of these cylinders. Well, if I now hop into my bore toolpath, I can get a much better look at how that toolpath is moving and acting at the bottom of that bore, even with my toolpath simulation on. Generative design was a huge push at AU, and it's pretty cool. If you've never heard of it, what generative design does is it builds your CAD model for you. That's right, folks. Skynet has arrived. In Fusion 360, you have access to generative design samples, and we've got the motorcycle triple clamp open here. What's up with this red and the green? Well, the red represents exclusion zones for the new design. And sometimes that means you got to extend it so that, for example, it doesn't preclude you from having access as you install the part or servicing it, say, with a screwdriver or tool. Then the green represents geometry that you absolutely need to have. So here, where our triple tree will actually interface with the motorcycle. So we've got that green geometry they call preserve, the red called obstacle geometry. You tell it what sort of materials you're going to use, which is really important, because what generative design is doing is it's making use of the strength of those material properties, everything from plastics up to things like Inconel, that we then have to tell Fusion how it's being used. So here we've got a few different torsion load constraints to tell it, how do I need to design this part to have it meet the design requirements, including the factor of safety. After you hit generate, it goes off to the supercomputers and does its work. And what comes back is absolutely amazing. Again, nobody created these models. The computer created these. The first time I ever heard about generative design was back when Autodesk was using it in the context of software called Dreamweaver. And they had software that read the Formula One rulebook, and based on its own interpretation of the rulebook, was able to build the new, at the time, new safety roll cages for a Formula One car. Nobody was involved. It figured it out on its own, and the outcome gives you hundreds, if not thousands, of options. Some of them are horrible. Some of them are pretty beautiful. Many of them are often a very organic shape or organic look. What's even cooler, though, is that you can adjust these outcomes based on your capability, whether you're going to print the part, machine it, casting, and so forth. This is a truck for one of the Datron longboards. And Gavin Bath from New Zealand, who's behind the new post-processor startup Massive, he took a stab at this generative truck design. So he literally told Fusion, okay, we've got some constraints here where we need to mount bearing blocks, and we need this solid object here, we've got a shaft through it. Otherwise, here's how much a person weighs, here's the kind of forces that are going to be applied. Oh, and we need this fitting here. Go ahead and build the geometry that's going to support that, subject to whatever constraints that I want. Let's say I want to have it die cast, or I want to do it on a 3-axis machine, or in this case, we're going to try to do a 5-axis machined version. This isn't the final version, but it's probably pretty close. But this is really cool because we already built a Datron longboard, video coming out on that in a few weeks. So it'll be really cool to consider swapping out one of our trucks for this 5-axis designed version. But I want to wrap up with the craziest thing that happened in Las Vegas this year at AU, which was during one of the presentations, they were talking about the passion of the fans. And they showed another company where an active and passionate user had gotten a tattoo of that brand. And fast forward about 2 hours later, and Brett from Vertigo Technologies in New Zealand had a Fusion 360 tattoo on his forearm. Shout out to Brett for that kind of dedication. As always, folks, hope you learned something, hope you enjoyed. Make sure to sign up for the email list for the Fusion Academies. They're like mini Autodesk universities, but they're much more affordable. They're kind of rifle shots into the Fusion 360 community with really good classes. There was one in Portland last year, and I believe coming up in 2020, they're going to have them both in Portland, Oregon again, and then somewhere in the Midwest or East Coast. But as always, folks, take care. See you soon.